Good afternoon. We'll go ahead and get started. Welcome to the PhD in Educational Neuroscience Distinguished Lecture Series hosted by Gallaudet University. Welcome to those here in the auditorium and to those streaming from across the country. This lecture series aims to honor world-renowned scientists in the fields of psychology, education, cognitive sciences, and neuroscience. These different fields and all of the interdisciplinary fields in between contribute to the new and growing field of educational neuroscience. They increase our understanding of the human mind and the neural mechanism of learning. This year's distinguished lecture series theme is From Mirror Neurons to Society: How the Brain and Experience Provide New Insights into Learning. With our distinguished lectures series in the heart of DC, we want to build bridges across fields and scientific communities in the area and across the nation. Everyone is welcome to attend, and we hope you enjoy these exceptional presentations. Our first presenter for this spring semester is Dr. Sian Beilock. We are honored to welcome her to the campus. She is a cognitive scientist who has received her degrees in both kinesiology and psychology from Michigan State University. Currently the 8th president of Barnard College. Before beginning her tenure at Barnard a year and a half ago, she spent 12 years at the University of Chicago. There she served on the faculty as the Stella M. Rowley Professor of Psychology and studied math, anxiety, and performance and gender differences. She's also She was a member of the Committee on Education and became the Vice Provost at the University of Chicago. Her work as a cognitive scientist has revolved around performance anxiety with a focus on success in math and science for women and girls. She wrote the critically acclaimed book, Choke: What the Secrets of the Brain Reveal About Getting It Right When You Have to. And she was awarded for her groundbreaking work the 2017 Troland Award from the National Academy of Sciences. She's a fellow of the American Association for the Advancement of Science and member of the American Psychological Association. The title of today's talk is Overcoming Anxiety in Math. Please join me in welcoming Dr. Sian Beilock.
Well, thank you so much for inviting me. This is a long time in the coming. I think my original invitation was 3 years ago, and I've had a lot going on. In that time, I took a new position leading Barnard College, which is the college focused on empowering women. That's related to Columbia University. But I still love answering research questions and doing some of my work, and I continue to have a foot in that field. So it's especially exciting to get to come out and talk to fellow scientists about the work that I've done and that my lab has done. And as a cognitive scientist, my work has really revolved around asking questions about what happens in the brain and body when we perform at our best. But I've been especially interested in what happens when we don't put our best foot forward. How anxiety, how awareness of particular stereotypes about how we should perform because of our member in a particular gender or racial or economic group affects our performance. And in my work, I've been really focused on trying to understand why sometimes we have anxiety or worries about performing a particular task, how that actually plays out to affect our performance, and understanding that, developing tools and techniques that anyone can use to perform better when it matters most. Today, given especially some of the work going on at Gallaudet, I wanted to talk about the work that my lab has done around the phenomenon of math anxiety, which is a fear or apprehension about math. And math anxiety is really an interesting phenomenon because, especially in the US, you don't hear highly intelligent, well-educated people walking around bragging, oh, I'm not a reading person. But you do hear them bragging, oh, I'm not a math person. And it turns out that women tend to be more likely to talk and profess to be anxious about math than men. And it's related to math performance. So my lab has been really interested in understanding what math anxiety is, where it comes from, how it develops, what are the factors that can improve or get rid of some of this math anxiety, what are the factors that can perpetuate it. And in doing so, we hope we contribute to our understanding of how to best educate children to go out and reach their potential in whatever they're interested in. So one of the issues around math anxiety was that researchers for a long time talked about it not developing until middle or high school. The idea that the math gets much more challenging, and maybe that's when students start worrying or being fearful about math. But my research team and I really wondered if there was evidence of math anxiety much earlier. And if there was it related to math performance? Was it something specific to math? Could you have anxiety about reading that would play out in the same way? And if it was related to math performance, why? Was it the anxiety that was causing poor math performance? Or was it doing badly in math leading to anxiety? And if so, understanding that, how could we address it? So we started actually by looking at the start of formal schooling in first grade to ask the question of whether young kids at age 6 and 7 actually profess to be worried or anxious about math. And for any of you who work with young kids, you know it's actually hard to get a lot of information out of them. But we developed a technique to do this, working with one of my former graduate students, Gerardo Ramirez. We actually developed a scale to capture math anxiety in young kids. So we had them look at smiley and frowny faces such as this, and we asked them questions. We had them point to the face. How would you feel when taking a big test in your math class? Or when you get numbers in your math book? Do you feel really happy? Or do you feel really worried? And we pulled kids out one-on-one from class, and we asked them several questions to get at their math anxiety. We also asked kids questions to get at their anxiety about reading, so something similar, but a scale about reading. And the question, our first question, was do some kids profess to have anxiety about math as young as first grade? And if so, was it more so on average than for reading? And if it was, did it relate specifically to how they did in math class in terms of math achievement? So what we found in several studies was that yes, there was basically a normal distribution of kids and their reporting of math anxiety. Here's one histogram from one of our studies. We can see frequency is on the y-axis. And what you can see across a scale of math anxiety from the very right being the most anxious to the very left being the least, some kids reported having math anxiety and some did not. On average, kids reported having more math anxiety than reading anxiety. And the question was, did this math anxiety correlate with their actual math performance? So in another segment of our study, we pulled kids out of class one-on-one and we did some math games, really designed to get at their math achievement. In this particular study, we used the Woodcock-Johnson applied problem set. We asked kids questions like, how many squares are there? Or if you have 7 pennies and you spend 3, how many pennies do you have left? And the question was, Did math anxiety across these students relate to how they did in terms of math achievement? And the answer was yes. What we showed was that the higher children's math anxiety, the lower their math achievement. So now we've started to get at this idea that even at the start of formal schooling, some young kids may have math anxiety, and it's actually related to how they do in math. But of course, the question we could ask is where this anxiety actually comes from. Is it related to doing poorly in math and then they develop anxiety about it? Or is it possible that they are inheriting anxiety about math from somewhere else in the environment, and that actually changes their own anxiety or how they process and perform math problems? So one place that we were actually really interested in looking is at the start of formal schooling, the kids' interactions with their teachers. We know that there's been research looking across studies, many different studies, meta-analyses, looking at the relationship between what one decides to major in and their anxiety about math. Does anyone have any idea what college major professes to have the highest level of math anxiety? You're ruining my joke. So if you ask psychologists, they always say psychologists. English majors will always say English. But actually, there's been several meta-analyses looking at studies of math anxiety across different majors. And the major with the highest level of math anxiety are people majoring in early education. This is a study done by Hembry in 1990. One of my previous postdocs, Aaron Maloney, who's now an assistant professor at Waterloo, Ontario, Ottawa, a university in Canada. Ottawa, great school. She's probably watching this and very upset with me right now. She's done an additional study really replicating these results since 1990, and it turns out that people going into major in elementary education have very high levels of anxiety about math. There's something that is quite homogeneous also about elementary education majors and elementary school teachers in the US. Does anyone know what it is? They're almost all women. In fact, 95% of early elementary school teachers in the US are women. So our question was, if some kids as young as first grade have math anxiety, and that math anxiety is related to their math performance, could it be there's some link between their exposure to teachers in the classroom who have math anxiety and what they learn across the school year? If this is the case, and we can show that at the beginning of the year there's not necessarily a relation between a teacher and her student's math performance, but there is at the end of the year, that could start to suggest a mechanism by which young kids develop math anxiety and it relates to their performance. So my colleagues and I did a study where we looked across the Chicagoland area. We recruited teachers and classrooms, and we went in and we measured teachers' math anxiety, and then we measured at the beginning of the year their students' math performance, and again at the end of the year. We also measured teachers' math knowledge for teaching. So if you are into this literature, this is an assessment developed by Deborah Ball, who's at Michigan, because we wanted to ask the question about whether it was the anxiety per se or the teacher's knowledge about math that was related to their performance. When we did this original study, we published the results in the Proceedings of the National Academy of Sciences. It was a pretty small sample. We had 16 teachers and about 200 kids. And what we showed was at the beginning of the school year, there was no relationship between a teacher's math anxiety and her students' math achievement. And that makes sense because students are randomly assigned to classrooms. But by the end of the school year, the higher a teacher was in math anxiety, the lower her kids' math achievement. And we found this effect only in the girls. And we know that kids as young as first grade often model based on same gender adults. And so we thought, well, this makes sense. The teachers are modeling in a way that the young girls are picking up on, and that's relating to their anxiety and math performance. But we also know that we had a pretty small sample, and we thought that if young boys are in this environment as well, there should be potentially some relation as well, if there's something about how the teachers are interacting with the kids. Now, we do know that boys tend to get more math input outside the classroom than girls, so there is an argument for why this would just be a relation between female teachers and their female students. But we really wanted to look at a large sample to see if A, we could replicate this effect, and B, whether or not there was any hint that the relationship between a teacher's math anxiety and her students' math achievement extended beyond just female teachers and female students. So we replicated our study with over 60 teachers and 600 students. And what we showed was at the beginning of the school year, again, there was no relationship between a teacher's math anxiety and her students' math achievement. But by the end of the school year, students who are in classrooms with teachers who are really anxious about math were performing worse in math. And we showed the effect was bigger in girls, but that it was also there in the boys. And here's the data. What you're looking at is the grade change across the school year on the y-axis. So kids are in school for about 9 months, so about 0.9 is 1 year. And what you see for the kids who are in classrooms with teachers who are lower in math anxiety, they're gaining more in math across the school year. Kids who are in classrooms with teachers who are higher in math anxiety, the red bars, are gaining less in math. And what we see is that there's an effect of teacher math anxiety, and it's bigger in the girls than the boys, but it's still there. And again, this relates to how we're thinking about our students at these young ages. If they're going into classrooms as young as first grade and they're encountering teachers who are high in math anxiety, and it's relating to what they learn across the school year, and also relating to our kids' attitudes about math, this is really problematic for how they go on. Because you could imagine a sort of compounding effect. What if you get 3 teachers in a row who are really anxious about their own math ability? How does that relate to your performance and your outlook about whether you could perform well in this area? We wanted to understand whether or not it was not only affecting children's performance, but actually what was happening in the classroom that might relate to anxious teachers and their ability to teach their students math. And in all of these studies, we're always accounting for teachers' math knowledge, their ability to teach. And so we were wondering about what's going on, what's happening with how these teachers are teaching their students math. Why are they learning less math across the school year and generally tending to feel more anxious about it? So we actually went into some of the classrooms and we recorded teachers interacting with their students around math. And we looked at teachers who were really anxious about their own math ability versus teachers who weren't, to try and understand how teachers who are anxious were conveying math differently than teachers who were less anxious. Because if we can understand that, then we can start to address with teachers how to help them teach in the classroom. Before we go into the specifics of what the teachers are doing, I want to say that there's a bigger issue here, and I think this goes back to an education and policy issue, and something I know that you at Gallaudet are really interested in. How we're recruiting people into elementary school teaching in general. So if we have majors of elementary school teachers or people who are interested in being teachers who are anxious about teaching math and anxious about math in general, that's essentially setting students up to be in classrooms where the teachers are anxious. One issue is how we're supporting those teachers, but another is how we're recruiting people who are interested in math and science into the teaching profession. And that's something that I think is a bigger issue, bigger than for my talk, but there have been several initiatives to get more teachers interested in math and science in the classroom. A lot of those initiatives at the national and government level have been focused on high school teachers and middle school teachers, and so I think there's really a place to look for how we're thinking about elementary school teachers. And one other aspect of this is when these initial studies came out, I got calls from several math professors and education professors across the country, and they said, this is really interesting. We've actually had pressure from our administrations to reduce the math requirements for elementary school teachers. Because one issue here is that if you're trying to attract more students to your college or university, you're trying to make majors that are attractive to them, and that could be majors where there's less math requirements. So if we're attracting in people into these early grades who are anxious about their own math ability and not thinking before we attract people in how we get different people into the teaching curriculum, we're really already setting ourselves up for, I think, subpar mathematical achievement of our kids. And we don't have any evidence to speak to this per se, but I actually could imagine, and I've hypothesized, that this is actually a relatively recent phenomenon in the US culture, because a couple generations ago, one of the only outlets that were open to women who were interested in math and science was teaching. Now we send women interested in math and science to all different sorts of professions, which is absolutely fantastic. But if we're not working specifically to bring women who are interested in math and science into the teaching profession, especially at young ages, I think we're doing our country at least, and our young people quite a disservice. Okay, so what are teachers who are anxious about math doing in the classroom that could potentially change how students are learning and performing and feeling about math? One thing that we noticed was that teachers who were worried about math tended to just spend less time on math throughout the school day. If math tended to be done in one particular time of day, they just spent less minutes doing math. They also tended not to integrate math throughout the day. You could imagine doing math in many different ways. When you're doing circle and calendar time, when you're talking about how many cookies you get as part of your snack, these are all math activities that could be integrated into everything that goes on throughout the day. And the teachers who are really anxious tended to do less of that. Another thing that we noticed is that teachers who were anxious about math tended to be more dogmatic in terms of how they taught math. There was a right and wrong answer. And they often didn't let the students work through the answers. So here's an example of one teacher who was doing math with her students. And you can see that she's asking them to measure how they draw a pencil. And she actually, in the question, gives them the answer.
All right, so to measure this drawing of a pencil. So instead of using 1 by 1, do you think that I should just start by using a 10? Yeah. Because otherwise it'll take me forever, right?
So we know that students can benefit from having to think and work through and actually do a little bit of work on problems. And what we showed was that teachers who were really anxious tended to be more likely to do the work for the students. There was less exploration of right and wrong answers, and when they were on a particular answer, they tended to be more dogmatic. We also showed that teachers who were anxious tended to put negative consequences associated with doing bad at math. So here's another teacher working through with her students, and she basically threatens them for not getting the problem right or talking about negative consequences.
No, she's going to get angry. I'm not getting angry. I'm getting nervous. Maybe we need to go back to kindergarten now.
So this idea that if you're not getting it right, you have to go back, that we're very dogmatic, less time on math, all of this comes together to have an impact on how students are learning and performing throughout the school year. And finally, we've also shown that this effect is stronger in girls than boys. And one of the ways we think this plays out is because students actually change or adopt stereotypes about who should be good at math. So to get at this, we actually gave students at the beginning and the end of the school year a story about a kid who is good at math and a kid who is good at science, or good at reading, and we asked them to draw the kid. And what we were interested in is whether kids who are in classrooms with teachers who are anxious were drawing stereotypical girls as being good at reading and boys at being good at math. And we showed that this wasn't the case at the beginning of the school year, but by the end of the school year, when students were in classrooms with teachers who were really anxious about math, the girls were more likely to draw a girl as being good at reading and a boy as being good at math. And so if we couldn't tell the gender, we would do sort of a debriefing and ask them. So it was clear that the girl was drawing the girl as being good at reading, and for this egghead on the right here, the girl described it as a boy. And what we showed is that for girls who were in classrooms with teachers who were more anxious, by the end of the school year, they were more likely to draw these gender stereotype roles, the girl at being good at reading and the boy at being good at math. And to the extent they drew that, they performed worse in math across the school year. So now we're starting to get some input about how these teachers and their anxiety relate to students' ideas about their ability to perform math and also relate to their math performance. But of course, it's not just teachers in the classroom that interact with our young kids. Parents are students' first teachers and most sustained teachers. And we've been quite interested in the impact of parents and their own anxiety about math on students' attitudes and learning in math and their math achievement. And we've also been interested in what happens if we can help support and essentially propagate parents to be more confident in their own math ability. And so several years ago, we actually partnered with a nonprofit that had developed an app and books to think about doing math with parents and kids together. And the idea was that oftentimes families think about bedtime reading. You do bedtime reading with your kids, but you don't often do bedtime math. So could we infuse bedtime math into the home in a way that parents and kids would address math in a fun and interesting way and actually look and see an effect in terms of what kids are learning and thinking in math across the school year? So we asked the question. We randomly assigned over 500 families to either do bedtime math with their kids. They got an app. It was preloaded with bedtime math. You can download it for free on iTunes or Android. It's there for everyone. It gives a problem of the day. And the idea is to do fun story problems with your kids. And you could either do bedtime math, or we had one that was bedtime reading, that with the same fun story problems but without the math content. So here's what bedtime math looks like. Here's a problem. It might be a story about something interesting like whipped cream. Whipped cream was invented about 500 years ago, and it's credited to a bunch of guys with long, unpronounceable names. Notice this is not for the kids to do alone. It's for the parents and kids to do together. And then there's a question. If you can whip 2 cups of heavy cream into 6 cups of whipped cream, how many cups of air did you whip into it? What's the answer? 4. Good. Did you get a little anxious? And so the idea is to have a fun interaction with your kids around math and to just infuse math into the vernacular. Again, parents often think it's the responsibility of the home to do reading, and they often don't think it's their responsibility to do math. That's the purview of school. And so our question is, could we use the parents as a vehicle to infuse a better attitude about math, especially for parents who tended to be anxious about math? And so we looked at the impact of bedtime math across the first grade year, and what we showed is that for kids who were randomly assigned to bedtime math, they had greater math achievement across the school year than kids who were assigned to bedtime reading. And we showed the biggest effect for kids in families where the parents were anxious. And the idea being that for kids in families where the parents were not anxious, they're probably already doing math content in the home. They might be talking about it or doing it more. But really where we showed this benefit were for the kids where the parents would maybe not do math or would be anxious about doing it with their kids. We published that data, and then we continued to follow these kids across several more years, from first grade to the end of third grade. And I should mention that parents in the first year used the app anywhere ranging from 0 to 6 times a month. It wasn't that you had to use it every day. And after the first year, everyone basically stopped using the app. Kids and parents move on to new and exciting things. But our idea was that perhaps what doing this app is doing is changing how parents interact with their kids. So you don't actually need the app going forward. You just need to change how the parents are interacting. And maybe it's changing the parents' own math anxiety. So we just published the findings of following the parents through and the kids through third grade. We showed that there was absolutely no change in parents' math anxiety. So parents who are anxious about math stayed anxious about math. Maybe that's not so surprising. We know that this math anxiety comes up early as first grade and perpetuates across the lifespan. But what we did show is that parents changed their expectations and values they placed on math for their kid when they were in the bedtime math condition. And that actually drove an impact of the bedtime math app on kids' performance. So what I'm going to show you now are data looking at kids' math achievement from 1st through 3rd grade. And I'm going to split it on the right side by parents who were anxious about math and didn't get bedtime math. And on the left side, you're going to see parents who got bedtime math and who were anxious and not anxious about math. So on the right side, you're going to see parents who were, well, let me make sure we get there, so I'll show you. Okay, here's the reading group. That's the left side, so I didn't tell you right. Ignore what I just said. On the left side are the kids who are in the control in the reading group. And what you can see is their math performance from 1st to 3rd grade. You see it goes up, and then it flattens out. It goes up, flattens out. This is the summer slide that people have talked about. We just show a summer flat, which I think some people have already talked about as well. And what you can see, the light gray bar are kids of parents who are anxious about math, and the dark gray bar are kids of parents who are not anxious about math. And what you see is that there's a difference as a function of parents' math anxiety. Kids who are anxious about math are not achieving as high of a level in math performance as kids whose parents are not anxious. But if you look at the math group, you see a very different pattern. What we did is we closed the gap between kids of low and high math anxious parents who use the bedtime math app. So kids on the right were from low and high math anxious parents, and they were randomly assigned to bedtime math. And kids on the left were from low and high math anxious parents, and they were randomly assigned to the bedtime reading group. The light gray bar are kids whose parents are anxious about math, and the black line are kids whose parents were not anxious about math. And what we showed is that we were able to close this gap in math performance among kids whose parents were anxious versus kids whose parents weren't, as a function of being exposed to the bedtime math. And again, we thought maybe the mechanism was that we'd get rid of the anxiety of the parents, but we didn't. What we did was we changed how much parents valued math and valued it and thought it was important for their kids, and this partially mediated the effect. And we're just finishing collecting data and analyzing data, looking at the interaction between being in a classroom where teachers are really anxious and getting exposed at home to the bedtime math app. So one idea is that if our kids are being impacted by teachers who are really anxious about math, can we be doing something at home in addition to thinking about how we dress the teachers to offset that effect? And what we show, just as a prelude, is that when you're doing bedtime math at home, it reduces the negative impact of the teacher's anxiety on kids' math achievement. So we're really excited about some of these avenues to affect math achievement and attitudes as well, not just through thinking about what's happening at school, which I think there's some larger societal and policy questions, but also in terms of what's happening at home with the parents. So I've told you a little bit about math anxiety, that it starts really early on, that we know it's related to kids' math performance, that one mechanism through which we think math anxiety relates to kids' math performance, or the onset of that anxiety, is through the teachers, and that kids' attitudes about math change when they have anxious teachers, and that actually affects their math performance. I also talked to you about the impact of the parents and their anxiety. We can see from this graph on the left here that there is a main effect of math anxiety in that kids who are from parents who are more anxious about math are learning less math across the school year. And we get rid of that effect when we give them the opportunity to do bedtime math and to interact around math in positive ways. But I haven't really talked about what math anxiety is in terms of how it impacts performance, and whether we can see evidence of math anxiety playing out at, say, a neural level. Because one idea here is that there still could be driven by being poor at math and the anxiety associated with it, rather than the other way around. And I hadn't really been able to address that question in earnest until I had a fantastic graduate student drop into my lab who's sitting over here in the corner, Ian Lyons, who's an assistant professor at Georgetown, and you should bring him over all the time to speak and do work now. I try not to bother him too much now. But Ian was really interested in understanding what was happening in the brain when people were anxious about math, and whether we could show evidence of this math anxiety independent of the actual math performance. Right? Because when you're just looking at math performance, you have all these things balled up in it. You have how they're doing on the math task, you have what's going on in the brain in terms of their anxiety, how they're processing the numbers, and so he designed just such a clever way to do this by actually bringing people into the scanner and essentially looking at neural activation for people who are really anxious versus not just when they were doing the math task, but when they were told they were going to do math. So what Ian did was he brought people into the scanner, and he didn't tell them ahead of time they were going to do math. But once they were in there, he said, surprise, you're going to be doing a math task, and you're also going to be doing some other things. And we're basically going to cue you that this math task is coming so that you know whether you're going to have to do something related to math or whether it's something related to reading. And what we were interested in is neural activation in response to just being told you were going to have to do math and how that related to the math performance, because that actually lets you separate out in a bit what's happening in anticipation of doing math and how it then might causally change how you're able to focus and do the math task. So basically, what we did is we presented people with a cue in the scanner for what they were about to do. As an example, they might see a yellow cue if they knew a series of math problems were about to come up. So you had to decide here whether 4 times 8 minus 15 equals 19. Is that true or false? False, good. And if you saw a white square, you'd have to say whether if these letters were reversed, they'd spell a real word. So this is a psychologist's idea of a joke. Was this your joke? This is a good joke. It almost spells experiment, but not totally, right? And so folks were lying in the scanner, and we jittered the presentation of the cue, which was 100% predictive of what they were going to do, and the presentation of either a block of math or word problems. And then what we asked was, what does neural activation look like when just the cue for math is present relative to the cue for doing a word problem for people who were high in math anxiety versus low in math anxiety? And Ian has found a number of fantastic he's looked at a number of fantastic findings in this realm, but I'll just show one that I think is really interesting. And what I'm showing you here is neural activation in response to the cue that you're going to do math relative to the cue that you're going to do word problem for people who are high in math anxiety relative to people who are lower in math anxiety. And what Ian showed was that there was more neural activation in areas in the parietal insula, the posterior insula, and the mid-cingulate cortex in people who are anxious about math versus people who weren't, just when they were ready to do math. And this is actually really interesting because, as you know, these areas are often invoked in a neural pain response, right? So if you prick your finger with a needle, or you have this visceral feeling of fear or threat, these are areas, the posterior insula and the mid-cingulate cortex, that are active oftentimes. And what Ian showed was that for people who are really anxious about math, these areas also became active when they were just getting ready to do the math task. And we think there are downstream consequences of this activity in terms of affecting how the frontal cortex processes actual math problems coming online. So something about the anxiety itself changing the cognitive resources we have to bring to bear to actually do the math problems. And so one of the things that we talk about is that oftentimes people say math is painful. And this neural evidence, I think, gives light to this idea that some of the same neural areas involved in actual feelings of visceral threat detection are involved when people who are anxious about math just know it's coming. And if this is the case, if there's something about the what-ifs and this onset of math or a negative situation that changes how we're able to focus and perform in a particular task, then what this suggests is that we should be able to do things in the running up, in the onset of doing something we don't like, that we're anxious about math, to actually change how people perform. That is, there should be psychological tools that we can implement to change some of these neural alarm signals, potentially to tamp them down, to help people perform their best when it matters most. And I know Ian has been looking at this a lot in math anxiety. We've been looking at it in other realms as well. So I'm not just interested in my lab in terms of being anxious about math. I'm interested in all sorts of situations where people might feel visceral threat or anxiety about doing a particular task. And one place that we've been really interested in looking is when people have different social identities and ideas about whether they should be able to perform well in a particular situation and how it affects how their performance plays out, and whether or not there are things we can do, brief psychological interventions to change how they're thinking about a particular situation and affect their performance. And so for this last part of the talk, I want to tell you about a new paper that just came out last month that was done with one of my postdocs, really decide to see if we could actually tamp down some of the neural alarm signals that come out of being anxious and some of the worries that we know people experience. So these are examples from when we asked students in one experiment who were worried about math just to think aloud about what they were thinking or to recall what they were thinking when they had to take a math test, right? I hope I don't look stupid. I thought about how boys are usually better than girls at math, so I was trying harder not to make mistakes, even though I did. There's no way I'm going to perform well. There's one that used to say, oh, I can't say it anymore, F word. But I figured once I became a college president, I had to take that one out of my slide. But really, people are really worried in these situations. And so if some of what we're seeing is not math incompetence, but instead the anxiety that's taking over their ability to perform well in these particular situations, are there things we can do to tamp down those anxiety, those worries, to help people perform better? So in a series of studies that a former postdoc of mine, Chris Rozek, did, he asked whether another type of threat could be tamped down by brief psychological interventions. And in this situation, he wasn't looking at math anxiety per se, but he was looking at the anxiety that's well documented that oftentimes low-income students feel about their ability to perform well in a particular situation. We know that there are gaps in socioeconomic status in terms of educational attainment, and a lot of this comes back to even before schooling starts and to preparation. But Chris's hypothesis was that just like anxiety about math, there's a component of this that goes back to how students are able to deploy cognitive resources in the moment when those neural alarm signals go off and essentially shut down their ability to focus. And so could we do something brief in the moment to help students who might be worried about how they're going to be judged or perform, especially in important and high-stakes testing situations? And so Chris chose 9th grade as a place to look because it's a place where there are really changes in the track students take in math and science. And he worked within a large high school where students came from very high socioeconomic middle and lower schools and very low socioeconomic middle and lower schools into the same high school. And this high school is really interesting because the 9th grade biology classes that the students took were a gatekeeper for whether they went into higher level math and science or stayed on a different track. And what Chris was able to do was across this entire high school of over 1,200 students across 2 years, test whether brief psychological interventions designed to reduce these anxieties before they took the high stakes exams at the beginning and the end of the school year could change how low-income students who we know have more test anxiety and more anxiety about performance than high-income students change how they actually perform on these tests. So we looked at 9th grade biology. He did this at the school level, really focused on socioeconomic status. And it was really based on this notion of what we talk about as rejection sensitivity, which is a term coined by clinical psychologists to talk about feelings of being undervalued or judged because you're worried about being of a minority in a particular situation. So oftentimes women experience this rejection sensitivity in male-dominated fields. Low SES students can experience it when they're in places that highlight SES. Minority students can experience it. And we know that it causes anxiety about how you're going to perform, much like math anxiety might play out. And the idea was that if this is impacting how low SES students perform on tests, could we do something brief to reduce this anxiety and help people perform better? So what we did is we randomly assigned within biology classrooms. There were several different biology classrooms across this 1,200-person freshman class. We randomly assigned students to either do a control exercise before their first and second high-stakes exam, or we asked them to do some brief interventions designed to reduce their worries in the moment. So this is what basically the study looked like across the school year. The school year began. In the fall semester, they did writing exercises right before their exams. Students were either asked to write about their thoughts and feelings on the upcoming exam, or asked to reappraise their emotions. So they were given basically a small article talking about the fact that when you have sweaty palms and beating heart, it's not a sign that you're going to perform poorly. It's a sign that your heart is shunting important resources to your brain to think differently about your emotions, or they did both of these together. So we basically had a control group where students just read about and studied for their upcoming exam, or they did one of these other exercises. The writing about their thoughts and feelings, where they were told, please take the next 10 minutes to write as openly and freely about what you're thinking, to reappraise your emotions, or do them both together. And there's a long list of research in clinical psychology showing that when people are ruminating and depressed, actually getting them to write, to journal, is a way of freeing up working memory. It actually reduces doctor's visits and some of the physical symptoms. And so we thought maybe some of this writing and the reappraising could have the same effect as brief interventions, especially if low-income students were worried and anxious about these tests at a higher rate, which we know they are. I should note that we, going into this, we were really interested in looking at income, and so we chose a class where there are not gender differences in performance, so men and women scored exactly the same on average in their biology exams, to really isolate out how being sensitive about coming in at a different income status could affect performance. So we did these brief interventions. The teachers did them. We weren't there. They took 5 or 10 minutes before their exam. The teachers didn't know what was going on in terms of what they were specifically doing, and then we collected their exam grades at the end of the fall semester, the end of the spring semester, and also right before the school year end, we had them do a survey where we asked them their feelings about the benefits of a little anxiety about taking a test. Is it good to have a little anxiety, or is it bad? What we showed is that for the high-income students, there was really no impact of our intervention. But for the low-income students, we were able to really change the passing rate for these sorts of courses. So this is our findings here. And the course passing rate is on the y-axis. And what you can see is that there's a huge income gap. The high-income students are passing the class at a much higher rate than the low-income students. But what we were able to do with our interventions, and again, these were all the interventions combined together. We didn't see any difference as a function of any of the interventions. They all showed the same sort of benefit. We were actually able to increase the passing rate by close to 18%. Now we're not changing their scores so much. We're only changing their scores like maybe 5%, but what we were showing is the low-income students were just under the passing rate for a lot of these classes, and we were able to push them over with these brief interventions. And we actually showed then in terms of the end of the year survey that lower income students who got the interventions were more likely to think that a little bit of test anxiety was good for them as before. So again, what all of this research, I think, shows is that it's not just what you know. Your anxieties, your emotions, your motivation matters. And it starts early. It starts early in life, at least at the start of formal schooling. And I think focusing on both what students are learning in class, but the environment in which they're being put in, whether it's the teachers or the parents or the types of supports they're getting to show what they know, is so important. And that's really what my lab has been involved in doing, asking the question of how can we employ brief psychological techniques, how can we think about the kinds of supports parents and teachers are getting to ensure that even from the start of early schooling, young kids are interested and excited about math and science, and kids who might have some anxiety or worried about their particular social identity in a situation are able to perform up to their potential. And there's a lot more work to be done, and I'm excited to have a great family of lab members who will continue that work many more years after I'm just watching and cheerleading on. So thank you very much. There's so many people to thank. If you want to read more about the work, I have a couple books designed for a general audience, and a TED Talk I gave last year, which was a really fun way to talk about what I'm doing to a broad audience. So thank you. Questions?
Thank you so much for your talk. The first question I have is both for teachers and for parents and anyone involved in young children's lives. How much do you see like a mismatch between actual math abilities and anxiety? So do you see many teachers who are actually pretty good at math but feel really anxious about it, or are people pretty accurate at sort of their self-perception?
Yeah, so it's a great question. There's certainly a relationship between people's math anxiety and their math ability, and I think it goes both ways, right? So it's being worried about math can lead to lower math performance, which leads you to worry more, but they are separable constructs. That's what I would argue. And there are people who are really anxious about math, but quite competent at it. I think, with teachers, it's a really interesting example to look at, because if you have people who are worried about their math ability but potentially have the competence, and they go into a profession to stay away from math, they never develop the competence they could have, and then they're put in these classroom situations. So I think it's part of who we're selecting into the classroom, and then it's part of how we're supporting them once they're in there. We have curriculum that change a lot. We go to the Common Core. Are we teaching math in different ways? The way that I learn math is quite different than the way my 7-year-old learns math. And I know I've confused her by doing it my way instead of what she's taught in school. And so I think there's a recursive cycle. I think there's some level of accuracy, but oftentimes people who are worried about a subject stay away from it, so they never have the opportunity to gain the competence that they could have to perform at their best.
A follow-up question. So is there any effort being put into working on teachers' math anxiety, just like fixing that part of the problem? Like, instead of working with the students, like take a teacher and help build their own skills and competence. Is that just in the world of education more so?
I mean, I think this is a great sort of problem for this group especially, because one of the first questions I asked as I was touring a lab previously is, how are you communicating what you're doing? Because I think it's really, it's a nut that needs to be cracked. Oftentimes teacher education programs are in different places than the cognitive science that's going on, and oftentimes these require school system initiatives, and faculty are trying to get tenure and focus on what they're doing, and so certainly there's been stuff done in pockets that we've done. So at Chicago, my colleagues and I ran teacher work circles over the summer to give teachers extra support in math and science, and some of my colleagues still do that, and there's other faculty that teach teachers over the summer, but it's got to be more of a systematic effort, and I think there are structural issues to how the science is set up and how it's implemented in the classroom and what the rewards are for researchers doing that work to get it out there. So it's still a problem that needs to be dealt with. And so one of the ways that we've been approaching this is how can we get at people more individually, like the parents. And my colleagues and I are doing several different things, and one is working with children's museums to think about how we can infuse some of that math learning that might happen in children's museums that parents might pick up. But we have sort of taken the lowest hanging fruit, like going in after parents, rather than thinking about reframing whole school systems, because it's hard. It's hard to do that.
I have that burning question, but I want to open the floor up to anyone else with further questions. Just come on up to the stage for any questions you may have.
Yes, thank you for your talk. I really enjoyed your talk. My question is related to your app, the one you use. I really love the app. I really like the fact that it's easy. It's on an iPad. Kids love iPads or phone. But so you see a wonderful reduction of the gap. How much do you think that was the fun of the app or the interaction compared to basic training? Because parents, the first thing they do is like, oh, let's do some more math, and just put the kid there on the table and do some more math. Do you think that the app had something that training math would have not?
Yeah. No, so I don't think there's anything so special about the app. I think it's a vehicle by which to get parents to talk to their kids about math and to think differently about math. And in fact, parents stopped using the app after the first year when we weren't kind of reminding them to do so. And I don't think you get those sustained effects unless you're actually changing the parents' viewpoints and the relationship between the kids and the parents. But I think there are not that many avenues for parents to interact in a fun ways with their kids around math, and this is one way to do it. Like you could set your kid up with math workbooks by themselves, but you're not changing the parents and the parents' input. And for me, I'm doing a little bit of me search with me and my 7-year-old, and it's not, we do the app sometimes, but it's how I've started thinking about infusing math into everyday life. So she asked for 6 gummy bears, and I give her 3, and I say, how many do you have to count to get to 6? She thinks I never am honest about numbers of things, but she's gonna be loving math. So it's about changing that mind frame in the parents about how they interact with their kids. And as you're thinking about, oh, I should be reading to my kid, which I think we've been successful in getting across the importance, although not everywhere, thinking about infusing that math talk, even just counting, pointing to things, talking about spatial mappings, all those things, I think what the app does is give you a little bit of a scaffolding to do that. Yeah, and often parents, there's been surveys done showing that parents think that math is the purview of schooling. You do math at school often. And then, if parents are anxious about it and we know you stay away from things you're anxious about, then that's just perpetuating it. We had one of our math studies written up in the New York Times, and there was a comment section, and one of the comments that I thought was most interesting was a mother who'd said, I judge my child's 2nd grade math homework by whether it's a 2-glass of wine night or a 1-glass night. Like the stress about doing the homework with the kid. And not only is that scary to read in itself, but also that it's totally fine to talk about it, right? It's, you have parents saying, oh, it's okay, I'm not a math person, you don't have to be good at that either. That sends 2 signals. One, that math is something you either have or you don't, not something that can be developed, and also that it doesn't matter. And we know that when parents think something is more important from young kids through high school, the kids value it more and do better in it as well.
So I have a question about the app also. I don't know if I missed it, but did you report on the math anxiety level of the 3rd graders? And is it possible if you can change their math anxiety that they become adults who are low math anxious and maybe
Yeah.
Teachers who are low math and
We have not reported on that yet, although we know from some of our other studies that when kids are doing better at math, their anxiety does go down, but that's one of the next papers to write. And the question is, do we see this sustained effect over time? So we actually have followed these kids through 5th grade, and we're just getting their 5th grade scores now, so we're really hoping to look at that and see over time. But it is possible that if we can get these kids excited and doing better at math early and reducing their anxiety, then we could develop kids and adults who are less anxious and parents, and yes, we hope we're going in that direction.
I'm trying to figure out how to word my question. I feel like if most elementary school teachers are female, what about male elementary school teachers, and what's happening with their interactions, especially with girl students and math?
It's a great question. We don't know the answer because we haven't been able to get a big enough population we just didn't do the study with them. So we would recruit 60 teachers and 2 or 3 would be men, and we didn't end up studying them. So it's a really interesting question. I think some of our newer work showing that when women are anxious about math in the classroom, it affects both boys and girls. Might suggest that if you have a male teacher who's anxious in the same way, you'd get some of these effects, but we have no idea.
Thank you. Hi, good afternoon. I'm very glad that we finally got to see you. I think I was the one who contacted you 3 years ago. So
I'm sorry. A lot has gone on.
And then, of course, Ilaria took over, so congratulations to her for making it happen.
She was persistent.
Really enjoyed the presentation. Thank you so much. And it's really perfect timing, actually, because March 9th we'll be having a STEM day for the elementary schools, and they've been asking us to go and provide workshops and so forth, and I wanted one of the workshops to be about numeracy. And it seems that you've talked about it a little bit. There's a lot of great information in this presentation that hopefully I'll be able to incorporate for their benefit. I agree 100% that obviously there's work that can be done, and we don't really put enough emphasis on numeracy in math. There is so much emphasis, especially in the home, on reading, and so we're seeing those consequences. I actually have 2 questions for you. One has to do with the word anxiety. I'm interested in the fact that you use the word anxiety, because I sort of could imagine a different word like self-concept or low confidence. It might send a different message. I think the word anxiety tends to, it's a diagnostic term, isn't it? And so it's something that, counselors use. And I wonder if for many deaf children, anyway, who are struggling with literacy, we want to be careful not to use diagnostic terms that then influence how they're understanding their sense of self. And certainly we're not qualified to diagnose in those ways anyway, but I wonder if a person has some anxiousness, and their brain activity is actually different. So I wondered about your use of the word anxiety and what other words we might employ to discuss this emotional reaction. Is it actual anxiety? Is it something else?
Yeah, I guess it depends on how you define anxiety. I tend to think about both a cognitive and physiological component in terms of worries and rumination, and also changes in physiological response, and we see both. So we know that when people who are anxious about math are confronted with a math task, their cortisol can increase, some of these sort of physiological anxiety responses, as well as their worries. But it's a point well taken that we don't want to talk about the phenomenon that we're trying to lessen in ways that increase it or underscore it or make it seem more concrete and non-malleable than I think it is, because I think it is malleable. We don't use it with the teachers and the students in the same way, but for research terms we talk about it. But I do think that the underlying point you're trying to get across, that this is something that can change, that's malleable, I certainly agree with in that way.
Thank you. Yeah, I do say that, I know teachers can change their attitudes, and in many ways, people think that they can. I'm just not a good reader, and that's the end of the story, or I just don't like reading. And teachers have a tremendous amount of influence in those areas attitudinally, so I think actually how we speak about it is quite important.
Yeah, and I think teachers do and parents do, and I've had anecdotal conversations with parents who say that, they're young, they're third grade. One I just had last week, who's the head of a very big lab at Columbia, said to me, my third grader came home and said, oh, I'm not good at math. And his reaction was really negative. Like, he was mad that she was saying this, and it sort of underscored her fear, instead of stepping back and saying, well, why would you say that? First of all, you're not good or bad at math. And it turned out that by working with her a little bit, she changed her attitude completely, and that's why the power of teachers and parents here are so important, because you could imagine that young girl coming home and saying, oh, I'm not good at math, and the mother saying, oh, I'm not a math person either, right? And just, that moment could be so pivotal.
Absolutely true. That connection between school and home is also very important. So moving on to my second question, the study that Ian did with the yellow cube and the white cube cueing what was coming. The white was used for a reading task or something else, and the yellow cube for math. I wonder if you had a control group where they were not primed in any way, so or maybe white would be used for math sometimes, or were there any other kind of groups that were using different colors or no colors?
Yeah, so Ian can answer this, but in this study we made the cue 100% predictive, right? But you may be doing something along this line now or thinking about it. We thought about making the cue predictive only a certain amount of times, but we really wanted to try and separate out the anxious reaction from actually doing the math. So we haven't done that study yet. Are you thinking about that? Ian's probably thinking about 100 things.
Yeah.
Yeah. Yeah. It's interesting, we're running a study.
I wonder if a yellow cue was priming for math and another color such as red was used for something else. I feel like white is a calming color, so I think even the choice of color.
I think I might have just used those colors as an example, and they were switched. Oh, we counterbalanced. See, that's why you need to have really fantastic graduate students in the lab. Of course we'd counterbalance. So some students got the white for the math and some got it for the reading. That's why this is a lab effort. And we worked really hard. I can't remember, we ran so many pilot studies to yoke the demands of the word task to the demands of the math task, right, in terms of reaction time and accuracy. I think you almost spent like a year doing that. Yeah. And I think I just wanted to run the scanning study, and Ian was like, no, we have to do one more task. I think I was like begging him to go in the scanner. I was like, we're close enough with the test. Well, thank you. Oh, one more.
We just want to thank you for your wonderful presentation. I do have a question related to the solutions you've come up with. We're talking about the math app and word problems and some writing exercises, but it still requires literacy skills and language skills. So I was thinking about parents who have deaf children. Many parents are hearing and don't sign. So we don't have the same discussions in our communities, and in terms of the emotional reactions around those tasks. And I wonder if there might be another approach, maybe through activities to diffuse the anxiety.
Yeah, I mean, I think it doesn't all have to be through language. Even doing activities like puzzles, anything where you can do math in a fun and interesting way. Even cooking has math components in it. There are all sorts of things that you could do. And I think part of it is just to get parents and kids interacting in non-stress-filled ways around these sorts of subjects.
And what about there was one of the experiments had students write about their emotions. What might be another way to approach that?
So I have a student who's been looking at whether drawing pictures could do some of the same things. I think that's interesting. And she's found some preliminary evidence that, yeah, it does help, especially for younger kids who might not be as comfortable with their writing. But we have more work to do there.
Wonderful, thank you.
Thank you again so much for your talk, and please, everyone who's here in the audience, please come join us for some late refreshments and accept this gift.
There's balloons.
Sorry to stand there before I explain it.
Thank
we really
you.
want to thank you for taking your time to come down. We know you are a very busy president of the university. We are very thrilled and lucky to have you here. Let's continue this at our late refreshments. We have some food and drinks, and everyone is welcome. Please come and we can all continue this conversation. It's in SLCC in the atrium, the large area, and if you don't know where that is, just follow us as we walk on out. Thank you.